Today we're going to be doing the first part of section 3.8, derivatives of inverse trigonometric functions. So let's look at example 1. Find the derivative with respect to x of arc sine x. So here I have sine and arc sine. We need to find the derivative of this, and it needs to be in terms of x. So the first thing we want to do is let's rewrite arc sine. So we know that it's the same thing as having y equals the inverse sine of x. Well, when you find inverses of each other, you usually interchange the x and y. So I could rewrite this sine y equals x. And if I want to take the derivative of this, to get what we have up here. So if I take the derivative of this now that I don't have inverses, I can go ahead and take the derivative of these. So the derivative of sine y is cosine y. But I need to use implicit differentiation because I want it in terms of x. And that would equal 1 because the derivative of x is 1. Now I need to isolate dy dx. So dy dx equals 1 over cosine y, which equals secant y. However, that's not in terms of x, and we want our derivative in terms of x. So I have, going back up to here, sine y equals x. So I can go ahead and draw a triangle and find secant y in terms of this triangle here. So here's my angle y. Okay. Sine is opposite, so it would be x over 1. And this adjacent side, I would just have to find using the Pythagorean theorem, and it would just be the square root of 1 minus x squared. So if I want to find secant y, the derivative of this, secant is, here's my angle y, secant is hypotenuse over adjacent. The derivative of this would be 1 over the square root of 1 minus x squared. By using our original triangle formula here, because secant y would be a hypotenuse over adjacent when my angle y is right here. Let's go ahead and do this again with cosine. So example 2, we want to find the derivative with respect to x of arc cosine, so it has to be in terms of all x's. I know that this would be y equals the inverse cosine of x, or cosine y equals x. And that's what I'm going to use to have my triangle to find the actual derivative of this. So I'm going to take the derivative of cosine with respect to x. So that would be negative sine y dy dx equals 1. Or dy dx equals negative 1 over sine y. So going back up here, I use this to draw my triangle. My 90 degrees here, my angle is y. Cosine is adjacent over hypotenuse, so that would be x1, and this would be the square root of 1 minus x squared. And we know negative 1 over sine y would be the same thing as cosecant y, which is hypotenuse over opposite. So my derivative would be negative 1 over the square root of 1 minus x squared. And that is how you derive your inverse trig derivatives. And we're not going to do that for every single one. So let's look at this. So the derivative with respect to x of inverse sine u, so this is one is in terms of u. In your packet, if those are not fixed, make sure you fix them to du over dx. would be 1 over the square root of 1 minus u squared du dx, where u is less than 1. And for cosine, it would be negative 1 over the square root of 1 minus u squared du dx, where the absolute value of u is less than 1. Because if it's greater than 1, then we have a problem. We'll have a negative under the square root. So in your packet, if you printed it, this might not be fixed, but I believe it now is fixed. Let's look at example 3. If y equals the inverse sine of 8x squared, find dy dx. So in order to find dy dx, that would be 1 over the square root of, this is my u, so I'd square that, 1 minus 64 x to the fourth, times the derivative of that, times 16x. And that would just simplify to 16x all over 1 minus 64 x to the fourth, and the square root of that. Let's look at this quick quiz. Which of the following gives dy dx if y equals inverse sine of 2x? Okay, so hopefully you've had some time to figure out your answer, and your answer should be C. So now let's look at the derivatives of the inverse trig functions. If u is a differentiable function of x with the absolute value of u less than 1, we have the following formulas. So the derivative of the inverse sine of u is 1 over the square root of 1 minus u squared times the derivative of u with respect to x. Cosine would be negative 1 over the square root of 1 minus u squared with the derivative of u with respect to x. Tangent would be 1 over 1 plus u squared times the derivative of u with respect to x. Cosecant would be negative 1 over the absolute value of u, the square root of u squared minus 1, with the derivative of u with respect to x. Secant would be 1 over the absolute value of u times the square root of u squared minus 1 times the derivative of u with respect to x. And the inverse cotangent would be negative 1 over u squared plus 1 times the derivative of u with respect to x. And all of these you're expected to know by memory for your exam. Let's look at example 4. Find the derivative of the inverse cotangent of x squared. So dy dx would be, using our formula, negative 1 over x squared, because that's my u, squared, plus 1 times the derivative of x squared, which is 2x. So simplified, that would be negative 2x all over x to the fourth plus 1. Let's look at the other example 4. Given y equals the inverse secant of 3x minus 4, find dy dx. So dy dx, looking at my formula, would be 1 over the absolute value of 3x minus 4 times the square root of 3x minus 4 squared minus 1, and then times the derivative of my u, which is 3x minus 4, so times 3. And just simplifying this so it looks a little prettier, it would be 3 all over the absolute value of 3x minus 4 times the square root of 3x minus 4 squared minus 1.